All right, so video problem 16b, I separated these two mainly because ice problems tire me out, so I'm sure they tire you out. So what we're going to do is we're just going to go through one other problem, the one on the screen, and we're going to look and we're going to try to figure out the equilibrium concentrations. Okay, notice in this problem we have both reactants and products. So what we have is a little more complicated than in some other cases. Okay? I also gave you a hint that you won't be able to use the assumption. Remember last time we did both the assumption and quadratic. This one I'm saying you can't use the assumption, right? Because you can only use the assumption as if x is small. Okay? We're going to actually show that x isn't small, but we'll deal with that later. Okay, so 16b. Let's anchor in. This will be a fun one. All right, so here I have H2 plus I2 goes to 2HI. They're all gases, so that means they're all in my equations for Q and for K. I have this. I can go ahead and I can start with my chart. I, C, E. All right, I am told 0.2 molar for this, 0.3 molar for this, and 2.0 molar. These are my initial concentrations. So I want to know what it is at equilibrium. So what I want to do next is I want to go ahead and I want to plug these in for my Q. Okay, my Q will be HI squared over H2 times I2. That's going to give me 2 squared over 0.2 times 0.3, or 66.7. Okay, so Q equals 66.7, K equals 5,020. If these were on a number line, Q would be lower than K. So it's going to have to shift towards the right. Okay? And notice how, what did I say? In order for X to be small, Q and K must both be greater than 100. Are they both greater than 100? No. That means X is not small. Uh-oh. All right, so let's go ahead and get to that point. All right, so we're shifting towards the right. So that means I have plus 2x minus x. I just looked at the last problem I did, and I made sure I didn't mess that up last time, but I didn't. All right, so plus 2x, notice 2, 2. Minus x, 1, 1. 1 in front of here, 1 here. All right, and it's shifting towards the right. Okay, so now, that means at equilibrium, I'm going to get 0.2 minus x, 0.3 minus x, and 2 plus 2x. I can now plug these in for my k. So my k is hi, that's 2 plus 2x squared, over 0.2 minus x times 0.3 minus x equals 5,020. Okay. All right, so now we need to go ahead and we need to find our x. I just said over here x isn't small, so I can't use the assumption. So what I need to do is I need to change this to get something that looks like the quadratic equation. Okay? So I need to get an x squared term, an x term, and then one with no x. All right, so what I need to do is I need to distribute these. Okay, all right, so it's 2 plus 2x times 2 plus 2x. All right, so if you remember, we have the FOIL method. So that's first, so 2 times 2 is 4. then outside 2 times 2x, inside 2x times 2, and then last 2x times 2x. Seeing that it's x squared, you didn't have to do the FOIL itself, but it's just a little easier, I think. 0.2 minus x, 0.3 minus x. All right, so 0.2 times 0.3 is 0.06. I'm just going to put this in brackets too. So that's first, then outside, so minus 0.2x, then inside, then last. Minus x times minus x gives me plus x squared. All right, and then this equals 5,020. Okay, let's simplify this. That would be 4x squared plus 8x plus 4 over x squared minus 0.5x plus 0.06. So I just took that, equals 5,020. Okay, now I'm going to rearrange it some more by moving this up here. So I have 4x squared plus 8x plus 4 equals 5,020 x squared minus 5,020 times 0.5, 2510x, and then 0.06 times 5,020. That gets me 301.2. Okay, now I need to go ahead and I need to rearrange this. So I move everything over. I'm going to move everything over to this side. So I'm going to subtract 4x squared from both sides. I'm going to subtract 8x, and I'm going to subtract 4. So that's going to get me 0 on the left-hand side equals 5,020 x squared minus 4x squared, okay, minus 2510x minus 8x plus 301.2 minus 4. Okay. All right, so that's going to go ahead and 5,020 minus 4x is going to give me 5,016 x squared minus 2518x, and then this is going to get me plus 297.2 equals 0. This is similar to the quadratic equation. Ax squared plus bx plus c equals 0. Okay. Now we could go ahead and plug this in to find x. But I'm going to give you one tip. Notice these are really big numbers. And what that's going to do is once I get to the next step, it actually makes life more difficult. So what I'm going to do is I'm just going to divide this whole thing by 5,016. So 5,016 x squared over 5,016 just gives me x squared. 2518 over 5,016 gets me 0.502x. And then 297.2 over 5,016 gets me 0.05925. And then 0 over 5,016 equals 0. That's why we can do it. It just makes life a little bit easier. All right, now let's go on to the next step. The next step is my A equals 1, my B equals negative 0.502, and my C equals 0.05925. And so I can plug these in. All right. I know you all love ice problems. They're so much fun. They're the best. All right, so b is negative 0.502. So negative b would be 0.502. With ice problems, you always want to give yourself a lot of room, make sure, because you're less likely to make a mistake. And when you do make a mistake, which I do, so you will too, you can find it easier. Right? So x equals 0.502 plus minus the square root. This term, this will get me 0.252. This will be minus something. .237 over 2. That gets me 0.502 plus or minus. And so I take this 0.252 minus 0.237, and I square root that, and I get 0.122 over 2. Okay? Now is where I get two solutions. So I get x equals 0.502 plus 0.122 over 2, or 0.502 minus 0.122. This is all because square roots can always be negative or positive, right? Because 2 squared equals 4, and negative 2 squared equals 4. So therefore, the square root of 4 is plus or minus 2, right? It's both of them. All right. Let's do this. So 0.502 plus 0.122 divided by 2 is going to give me 0.19. Oh, sorry, no, that's the wrong one. 0.502 plus 0.122 divided by 2 will get me 0.312, or 0.502 minus 0.122 divided by 2 will get me 0. All right, so x equals one of these two. So now I have to go back to my ice diagram, which I had somewhere. I had it right here, and I need to basically start over, and I need to put in these two possibilities. So let's say x equals 0.312, or x equals 0.19. All right, so if x equals 0.312, 0.2 minus 0.312 will get me negative 0.112. 0.3 minus 0.312 will get me minus 0.012. 2 plus this, or 2 plus 2 times this, will get me 2.624. Okay? If I do 0.2 minus this, I get 0.01. 0.3 minus this gets me 0.11. And then 2 plus 2 times 0.1 gets me 2.38. All right, so which one is the right one? Well, the one that doesn't give me negative concentrations. Okay? So these are my answers. Let's go ahead and check our work, because we went through a lot of work and we could have messed up at some point. So let's go ahead and put these back in. So k equals hi squared over h2 I2 So I plug these in, 2.38 squared over 0.01 and 0.1. 2.38 squared is 5.6644. 0.01 times 0.11 equals 0.0011. So now I do that, and I get 5,149. Okay. Notice how I started off at 5,020, right? Even though, hey, it's off by 100, it's off by 100 out of 5,000, right? So it's not off by that much, right? If I do 5,149 minus 5,020 over 5,149, I get 2.5% off. Right? So it's not off by that much, right? So it's okay. All right, let's go ahead and just put this on the screen as a review. So the first thing we do is we make our ICE table. We figure out which way it shifts. In this case, it shifts right because my Q is smaller than my K. Then I go ahead and I put in for all my values in terms of X. I then put those into my K. And now I need to take this and I need to use the quadratic equation. Why do I have to use the quadratic equation? Because notice Q and K, they're not very close together, right? So that means that the shift is going to be pretty big. Okay? All right, so I rearranged until I got something that looked like the quadratic equation. I did one more step to make it a little simpler. I could have used this and plugged it in and gotten a value for X, but it would have been a little bit more annoying. So I did it like this to make the math easier. I get two values for X. I go ahead, plug those back in. One gives reasonable values, one gives me bad values. And then I should always, always, always check my work just to make sure I'm close. All right, so that is it for this lesson. Hope you good luck on the test that you took today, and talk to you later.